We're now going to discuss the first law of thermodynamics. The first law of thermodynamics is a law of conservation of energy, and it states that the change in internal energy is equal to the negative of the work done by the gas plus the heat either added or removed from the gas. Now, we already know what work and heat are. They're both changes in energy. Work is mechanical energy, heat is thermal energy. So let's talk about this new term. So this is the change in internal energy. And this includes all of the kinetic energy associated with all the different ways the molecule can move. So this includes X, Y, Z, translational motion, all the different types of rotational motion, and any sort of vibration that you might have in the bonds. It also includes any potential energy stored in the bonds themselves. This does not include gravitational potential energy, so whether your gas is sitting on a table or sitting on the floor, that's not going to change the internal energy. And keep in mind that this is the change in internal energy, not the internal energy at any one moment. So we can determine what the change in internal energy is by looking at state variables and seeing one moment or state of the gas compared to another moment or another state of the gas. We cannot find the internal energy at any one particular moment. So we're always finding a change based upon how the different state variables change. Alright, so let's talk about how we're going to calculate the change in internal energy. The change in internal energy is going to equal the number of moles times the molar specific heat at constant volume times the change in temperature. And we already learned earlier how to calculate the molar specific heat at constant volume. So remember, for a monatomic gas, it's 3/2 times R. And for a diatomic gas, it is going to be 5/2 times R, because you have those rotational energy states. And because this is a change in energy, as long as you're both in Celsius or both in Kelvin, it will work. Now, when we use the first law of thermodynamics, the change in internal energy is path independent. So you can actually do final minus initial with the change in internal energy. But work and heat are what we call process variables that are path dependent. So if you have a multi-step problem, you can't just do final minus initial. You have to do the work from 1 to 2 and then 2 to 3, and the heat exchange from 1 to 2 and 2 to 3, and find the net of both. You can't just do 1 and 3 and subtract the 2. You have to actually do each step, because those are path dependent. The change in internal energy is not path dependent. So you can do 3 minus 1 with that particular term.